Hi everybody. So we have made ourselves very well versed with how to construct a histogram for a continuous frequency distribution when the class intervals given have equal size. After that, we also made ourselves well versed with the case when we had to construct a histogram for again the continuous frequency distribution, but this time with unequal class intervals. And now it's time to talk about constructing histogram for frequency distributions which are not continuous. The moment I say that they are not continuous, I am talking about the very frequency distribution made in an inclusive manner. So here we are going to talk about histogram for frequency distribution whose class intervals given are inclusive. The moment I have said inclusive, that means class intervals are not continuous. So in this case, we are going to talk about the distribution which is not continuous. That is, when the class intervals given are inclusive. The moment I say that the class intervals given are inclusive, I am actually trying to say that the upper limit of any class interval is first of all included in that class interval. Why? Because the upper limit of one class interval is not equal to the lower limit of the other class interval. Is it understood? Complete opposite of the exclusive case. In the exclusive case, what used to happen? The upper limit of one class interval was equal to the lower limit of the other class interval, the next class interval, and therefore we said that the upper limit of any class interval is not included as a value in that class interval. It will be included as a value in the next class interval because it is sitting as the lower limit of the next class interval. So over here the lower as well as the upper and everything between the lower and the upper limit is included in a class interval, and the upper limit of a class interval is not equal to lower limit of the class interval, which is what makes our distribution discontinuous or not continuous. How to represent such a frequency distribution graphically? Now try to recall both the cases of construction of histogram that we have done are for continuous cases. One was when the class intervals were of equal size and another was when the class intervals were of unequal size. But the best part was that in both the cases the distribution was continuous. Is it clear? The upper limit of one interval was equal to the lower limit of the other. Now in this case, what happens is, in the inclusive case, you will be given class intervals of the same size but discontinuous. Okay, that means upper limit of one interval is not equal to lower of the other. So somehow we are going to modify and adjust some entries in this distribution, especially the class intervals basically, and make the class intervals continuous. The moment we modify the class intervals in this case and make them continuous, they were first what? Discontinuous class intervals with equal size. Now they have become, after modification, continuous class intervals with equal size, falling in the first category whose histogram construction we already know. So how to modify a discontinuous case of class intervals with equal size to a continuous case of class intervals with equal size, and then draw the histogram for that case which you already know. Let's see this. So you have class intervals with you. This is the question. Let's tackle this question, and this question is going to lay before us the foundation and the methodology to tackle such type of problems. So you have class intervals and you have frequencies. So it is 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30 to 34. Frequencies are 300, 980, 800, 580, 290. So this is the data given Of course, you can identify that this data is of a frequency distribution. And in here, the class intervals that you can see are clearly discontinuous, right? So how to tackle such a problem? You can see that the upper limit of this class interval is not equal to lower of the other. Upper limit here is not equal to the next lower. Upper limit here is not equal to the next class interval's lower limit. Again, upper limit of this class interval is not equal to the lower limit of the next. So this is a discontinuous case, but the fact is that each class interval is of the same size. Please mind it, in each class interval, the lower as well as the upper values are included. So 10 to 14 consists of 10, 11, 12, 13, 14. That is 5 values. So 10 to 14 is, what is the class size? 5. 15 to 19, 15, 16, 17, 18, 19. All these 5 are included. Again, the class size is 5. Again 5, again 5, again 5. So all the class intervals are of the same size, but the situation is that they are discontinuous. So what are we going to do is, we have these original class intervals with us as 10 to 14, 15 to 19, 20 to 24, 25 to 29 and 30 to 34. We modify these class intervals and we create new class intervals. The best part is that they have the same size. Somehow if I just incorporate continuity in these class intervals, I will have continuous class intervals with the same size, and that would be the perfect scenario for me to go ahead with the construction of histogram. So in here, how to actually modify these class intervals so that they become continuous. That means if I go by the layman way, I am trying to say that the upper limit of one class interval is equal to the lower of the next. Upper of 1 is equal to lower of the next, upper of 1 is lower of the next, upper of 1 is lower of the next. How to modify? In here what we try to do, we pick up the lower limit of any class interval and subtract it from the upper limit of just previous class interval. So suppose I pick up 20. This is the lower limit of 20 to 24 class interval, and I pick up the upper limit of the just preceding class interval. And this I subtract. The value that I try to find is h. H is upper limit of one class or lower limit of one class interval minus upper limit of the previous class interval, just previous class interval. So you will have this to be equal to 1. You can pick up lower limit of any class interval. Pick up 30 and pick up 29, because 30 is the lower limit of 30 to 34 class interval and 29 is the upper limit of just preceding class interval. 30 minus 29 is also 1. Similarly, 25 minus 24 is also 1. 20 minus 19 is 1. 15 minus 14 is 1. So you can pick up lower limit of any class interval. Of course, not the first class interval, because you don't have the upper limit of the previous class interval then. Fine. So you pick up the lower limit of any class interval and then you do minus upper limit of just preceding class interval, that is the value of h. In each case you are getting h equals 1. 30 minus 29 is 1, 25 minus 24 is 1, 20 minus 19 is 1, 15 minus 14 is 1. The moment h is 1, I modify my class interval on what rules? If a to b is my class interval, it is modified to a minus h by 2 to b plus h by 2. So all the class intervals which are from a to b are actually now going to be written as, in context of this h, as a minus h by 2 to b plus h by 2. In this case, in our case, h is 1, so 10 to 14 class interval will be modified to what? 10 minus 1 by 2 to 14 plus 1 by 2. Similarly, what will this be modified to? This will be modified to 15 minus 1 by 2 to 19 plus 1 by 2. Then you have this will be modified to 20 minus 1 by 2 plus 24 plus 1 by 2. It's not plus, this is 2. We have to subtract h by 2 from the lower limit and add h by 2 to the upper limit. H is 1. That is why we are subtracting 1 by 2 from the lower limit and adding 1 by 2 to each upper limit. This will be what? 25 minus 1 by 2 to 29 plus 1 by 2. And this will be modified to 30 minus 1 by 2 to 34 plus 1 by 2. right? What does this become? So based upon this rule, we now have our new class intervals as 9.5 to 14.5, 14.5 to 19.5, 19.5 to 24.5, half is just 0.5, again 24.5 to 29.5 and 29.5 to 34.5. And that is the accomplishment of our aim. Why? Because we have succeeded in making our class intervals continuous. The upper limit of one is equal to lower of the other, upper of this is lower of the next, upper of this is lower of the next, upper of this is lower of the next. Moreover, the class size is also the same. 9.5 to 14.5, please try to understand now the case has become of exclusive, so you are not going to include the upper limits in the class interval. From 9.5 to 14.5, you have how many entries? 9.5, 10.5, 11.5, 12.5 and 13.5, not 14.5. We don't include the upper limit in the case of exclusiveness. So here I have class size as 5, again from 14.5 to 19.5 with 14.5 included, 19.5 excluded. That means 14.5, 15.5, 16.5, 17.5 and 18.5, that is it. 19.5 you will not be including. So you again have 5 entries, again 5, again 5, again 5. So this is the case of continuous frequency distribution with equal class intervals. So here with these class intervals, I have my frequencies given to me as, frequencies will not change, they will be the same, 300, next was 980, then 800, then 580 and then 290. Is it clear? And now this much is something that you already know how to draw the histogram of. So let us quickly accomplish this of drawing the histogram for the case of continuous frequency distribution with equal class size. How do you proceed? You draw the x-axis, you draw the y-axis. The moment you draw the x-axis and the y-axis, you know that what is the x-axis representing and what is the y-axis representing, right? So you have horizontal line, you have vertical line. The horizontal one is your x-axis and the vertical one is your y-axis. The frequencies are marked along the vertical line and the class intervals are marked along the horizontal line. Of course, this is 0. Fine. Now, we have to mark the class intervals on the x-axis and frequencies on the y-axis. Let us first talk about the x-axis. We have to choose a suitable scale to mark our class intervals. We have to choose a suitable point from where my scale will start on the x-axis. And if it is not starting from 0, I will draw a kink right in the beginning. We know all this. My class intervals are actually 9.5 to 14.5, 14.5 to 19.5 and so on till 34.5. So my class intervals are beginning from this value 9.5. So my scale on the x-axis will be beginning from 9.5. So scale on x-axis begins from 9.5. So of course it's not beginning from 0, so I will be drawing a kink in the beginning, this break, and I will be beginning my scale from 9.5. Now here, how should I take the divisions? Of what length should I take each division so that I am able to incorporate the max value, which is 34.5 in my class intervals as well on the x-axis comfortably. So I will be taking what? 9.5 to 14.5 is my first class interval, 5 unit gap. So I will be taking one big division is of 5 units. So let's take that. One big division on x-axis is of first question says the difference between the highest and the lowest value of the given observations is called what? Now you know that out of all the given observations, if I pick up the largest valued observation and the lowest valued observation and I actually create the difference between the highest and the lowest, that is called my range, right? And the difference between the upper and the lower limit of the given class interval is called what? I have a class interval a to b. What is b minus a called? It just gives you the class size. What is the width of that class interval? It gives you the class size, right? Let's talk about the next question. It says that in the class interval 10 to 20, 20 to 30 and so on. So it is just giving you a format of the class intervals taken. The class intervals are like this: 10 to 20, 20 to 30, 30 to 40 and so on. It is saying 20 is taken in which class interval? Now you know that this is the exclusive case of writing class intervals, right? In which case what happens? The upper limit is not included in the class interval, but the lower limit is certainly included in the class interval. So in the class interval 10 to 20, values from 10 to 19 are there, 20 is not there. 20 is actually in this class interval, that is in 20 to 30, because it is sitting as the lower limit, and lower limit of the class interval gets included in the class interval. In the class interval 20 to 30 are values from 20 to 29, 30 is excluded. So 20 is excluded in 10 to 20 class interval, but 20 is included in 20 to 30 class interval. So 20 is actually sitting in 20 to 30 class interval. Next you have the mid value of a class interval is 42. What do you mean by mid value? Mid value means class mark. It says class mark of 20 to 30, or which class interval? Okay, so class interval is not given to you. The mid value of this class interval, suppose x to y, that is class mark of x to y class interval is given to you as 42. This is my class interval. If the class size is 10, so class size of x to y class interval is 10. Then find out the value of upper limit and lower limit, that is x and y. What is class mark of a class interval? Y plus x upon 2, that is the mid value of that class interval, gives you the class mark. So this means if x to y is the class interval, its class mark is 42, that means x plus y upon 2 is 42. And what is the class size of x to y class interval? Width, upper limit minus lower limit. So you have y minus x is 10. If x plus y is 42, that means x plus y is 84. So you have x plus y is 84, y minus x is 10. Just solve these two equations. You have x plus y is 84 and minus x plus y, or y minus x is 10. When you add, you get 2y equals 94, which implies y equals 94 upon 2, that is 47. And if y is 47, what is x? Minus x is 10 minus 47, so minus x is minus 37, or x is 37. So your class interval is 37 to 47. You can see that if 37 to 47 is the class interval, what is the class size? 47 minus 37, which is 10. So yes, y minus x is 10, or class size of x to y class interval is 10. Moreover, what is the mid value? 47 plus 37 upon 2. 47 plus 37 is 94. 94 upon 2 gives you what? 7 plus 7 is 40, it is 84. 37 plus 47 is 84 upon 2. When you do, you get 42, and therefore class mark of 37 to 47 class interval is 42. So your class interval is 37 to 47. What is the upper and lower limit? Upper limit is 47, lower limit is 37. Clear? Let's look at the next question. It says that the following observations have been arranged in ascending order. So the observations given to you have already been given to you in an arranged fashion in the ascending order format. If the median of the given data, now see, first of all you have to remember this, that whenever the observations are given to you, this collection of individual observations are given to you, before finding the mean of such a data, you need to arrange them in ascending or descending order. So if the question is talking about median, I have to be sure that the given data is in some form of arrangement. It is already guaranteeing that these values are being arranged in the ascending format, so we don't need to worry about that arrangement. Median is given to be as 63, find the value of x. Median is given as 63. How do you get the median? You count the number of observations after arranging them in ascending or descending order. Right now they are arranged in ascending order, just count the number of observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your number of observations is 10, which is an even number. And therefore you know median is what? It is value of n by 2 n by 2 plus 1th upon 2 observation. That means you catch hold of the n by 2th observation, 10 by 2th observation, that is 5th observation, plus 10 by 2 plus 1, that is 6th observation, divide their sum by 2. That means 5th plus 6th observation upon 2. What is the 5th observation count now? It's already arranged. So the places, the positions of elements are now fixed. First, second, third, fourth, fifth. Fifth value is x. Sixth is x plus 2 upon 2. This gives you 2x plus 2 upon 2, which is x plus 1. So your median is coming out to be x plus 1, but median is already given to you as 63. So you are getting 63 equals x plus 1, or x is 63 minus 1, that is 62. Cool enough? Next question says that 30 children were asked about the number of hours they watched TV programs in the previous week. The results were found as follows. Okay. So these are the number of hours: 1 hour, 6 hours, 2 hours, 3 hours, 5 hours, and so on up till 12 hours. Make a grouped frequency distribution table for this data, taking the class width as 5 and one of the class intervals is 5 to 10. So they are giving you one of the class intervals. This doesn't mean that you have to begin your class intervals with this class interval. So we are going to first of all talk about class intervals. The next column is of tally marks, and the third column is of respective frequency. Okay. Now see, if you look at the data, minimum number of hours is 1, right? That means I cannot keep 5 to 10 as my first class interval, because there are hours less than 5 as well. So let me begin from 0 to 5. If I take 0 to 5 as my first class interval, I will actually be considering the values 0, 1, 2, 3 and 4. 5 will be excluded because next class interval will be 5 to 10. So when upper limit of one class interval is lower limit of the next class interval, I am talking about the exclusive way of making the frequency distribution. So I will be beginning from 0 to 5, then 5 to 10, 10 to 15, 15 to 20. Do we need more intervals? Let's see. Maximum here is 17, yeah. So that much will be covered in 15 to 20 hour range. We don't need 20 to 25. There is no data concerning or lying between 20 to 25. Is it clear? This is satisfying both the conditions. One of the class interval is 5 to 10 and the class size of each class interval is 5. Clear? This is the exclusive case. Please mind it. In the interval 0 to 5, I am considering 5 values: 0, 1, 2, 3, 4. 5 is not there. In the interval 5 to 10, again 5 values: 5, 6, 7, 8, 9. 10 is not there. So upper limit is not included in the class intervals, lower is included, and everything in between them is included. Now, between 0 to 5, let's see. 1, 2, 3. 5 is not included. Between 0 to 5, this is there, this is there, this is there. Then this is there, this is also there, this is there, this is there. And that's it. This is between 0 to 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is the frequency. 10 students or 10 children are there out of 30 children who are watching television for 0 to 5 hour range. That means 0, 1, 2, 3 or 4 hours. Next we have 5 to 10. So 5 is there, 6 is there, again 5 is there, 8 is there, 8 is there, 10 is you cannot include, then again 8 is there, 6 is there, 8 is there, 5 is there, 9 is there, 6 is there, then again 8 is there, 7 is there, that is it, right. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is the frequency here. Next is 10 to 15. 10, 11, 12, 13, 14. That's it. Here we have covered all 10, 11, 12. So this is there. 10 is included. This is included. 15 we cannot include. 10, 11, 12, 13, 14. Yes. Okay. 10 to 15. So how many values here you have? 1, 2, 3, 4 and 5. So 5 is the frequency of 10 to 15. 15 to 20, 17, 15 and that is it, 2. It is 2. If you will add, you will get 30. So out of 30 children, 10 children are watching television in this much range of hours, 13 children are watching television for this much range of hours, 5 are watching television for this much range of hours and 2 are watching television for this much range of hours. This is my group frequency distribution. Let's just draw the tally marks. 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 13, how will you write 13? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 5, 1, 2, 3, 4, 5, 2, 1, 2. Clear? Let's move to the next question. It says that the relative humidity of a certain city for a month of 30 days was as follows. Construct again a group frequency distribution table. Now the class size is not mentioned, but the class intervals are given, just 2 are given. Okay, so with taking the idea of class size from these class intervals, I am going to write all the class intervals. It also asks you which month or season do you think this data is about and what is the range of this data. Let's first talk about the group frequency distribution. So I'll have class intervals, again tally marks and frequency. Clear? Now it's given to you 84 to 86, there is no value beneath 84, so I am going to take 84 to 86 only as the first class interval. Next is 86 to 88, so next will be 88 to 90. What is the class size? Of course you can judge the class size, it is 2. In 84 to 86, what am I including? 84 and 85, that is it. 86 is not included, 86 is included in this class interval. It is again the exclusive case. Then 90 to 92. 92 to 94, 94 to 96, 96 to 98. Can I stop over here? Okay, so let me see. I have numbers beyond 98 as well. Let me take 98 to 100. But I don't have anything beyond 100, so I stop over here. Clear? How many values are there between 84 to 86? Now please mind it, when I am saying between 84 to 86, I am just talking about 84, 85, not 86. That means anything between 84 and 86, including 84, excluding 86. So here between 84 and 86, so I have what? This is not there, this is not there, 84 to 86, here I have nothing, this is there. And here also I have nothing. So 1. 86 to 88. 86 to 88, this is not there. 86 to 88, this is there. 1. And that is it. This is also beyond 88. So you have just 186.5. 88 to 90. Yes, you have this 89.2 and that is it, because 90 you are not allowed to include. So again 1. 90 to 92. Okay, let's see. 90 to 92. This I will be including. 90 to 92. No, no. Yes, this is also